Hello and namaste everyone. Welcome to my channel Engineer Star. This is the 14th lecture of uh, the topic line integral, and the question is prove that f vector is conservative vector field. So to prove any vector as conservative, we need to show that curl of f vector is 0. So curl of your vector is I d by dx plus j d by dy plus k d by dz is this, and cross product of a function of a vector f vector y cube I plus 3x y square plus 2e to z j vector plus 2y e to z k vector. So for cross product, we have to write I, J, K in first column, and in second column, in second row, we have to write del by del x, del by del y, and del by del z, and in last column, the coefficient of this I vector of the f vector, that is y cube, similarly 3x y square plus e to z and 2y e to z. I, J, K. So first we need to take this first row and first column element, that is I vector, and cancel the first column and first row, and remaining is del by del y of 2y e to z, that is uh, I vector del by del y of 2y e to z, that is 2 is constant, so taking out this, and with respect partial derivative with respect to y, so this will be z term will be constant, and del y by del y is 1, so it is 2e to z minus this, so it is del by del z of this. So here is no z, so derivative of constant is 0, so there is derivative of e to z with respect to z is the coefficient of z, that is 2, will come, and remaining will be as it is e to z. So this and this cancels, for second we write j vector and remove this column and row, and remaining is this. There is no x, so it is derivative of constant is 0, and this, there is no z, so everything other than z is constant, so derivative of constant is 0. And finally k vector, and cancel this column and this row, remaining is this, del by del x of 3x y square plus e to z, so 3y square will be constant, and derivative of x with respect to x is 1, so 3y square minus this, derivative of y cube is 3y square, so this and this cancels, 0 minus 0 is 0, and this minus this is also 0, so it is 0. Since curl of f vector is 0, so it is conservative vector field. Now we have to find scalar potential function phi. To find this, we have f vector is grad of phi, so taking dot product dr vector on both sides, we get f vector dot dr is y cube dx plus 3x y square e to z dy and 2y e to z dz, and grad phi of dr vector is simply d phi. Now y cube dx as it is and 3x y square dy plus e to z dy plus 2y e to z dz. Now from these two equations we can write the highest power is this, so derivative of y cube, and another function is this x, so derivative of y cube x is same as x y cube. So expanding the taking derivative of this, we can check first function as it is and differentiation of second, and second function that is x as it is and differentiation of first function that is 3y square dy. So it is y cube dx and 3x y square dy. So we can write this as derivative of y cube x or derivative of dxy cube. Now from these two, this 2 is same as this because differentiating this we should get this. So first function as it is and the differentiation of this is 2, this 2 and e power 2z plus second function as it is and differentiation of dy. So it is e to z dy and 2y e to z and dz because differentiation of e to z is 2e to z, and by chain rule differentiation of z. Finally, on integrating we get phi equals xy cube plus y e to z and the constant c. This much for today. Hope you enjoy the video. Thanks for watching. Like, share and subscribe this channel, and if you have any question then feel free to comment it down.